Hello everyone and welcome back to my channel. Today we'll be learning algebraic proof. Let's get started. Okay, so there are many types of algebraic proof, and in this video we will be talking about the first 8, or the main eight algebraic proofs. So the first algebraic proof we have is the addition property of equality. So addition property of equality. Now this algebraic proof basically says if A is equal to B, then A plus C has to be equal to B plus C. Now this makes sense. Say for example we have 2. So A is 2, which means B is the same as A, so B also is 2. And so that means 2 plus any number, we'll just say C is 3. 3 has to be equal to B, which is also 2, plus 3. So both of those equal 5. That is the addition property of equality. Now moving on, we have the subtraction property of equality. So prop of equality. Now I'm just shorthanding this because it's a little lengthy to write, but I hope you get it. So this is a subtraction property of equality. So the subtraction property of equality is like the addition property of equality, but instead of having A plus C, we have A minus C is equal to A B minus C. So this makes sense too. So just like the last problem, if we take A is 2, meaning B also has to be 2, we would get 2 minus 3 is equal to 2 minus 3. And both of those equal -1. Okay, now let's move on to the third type of proof. The third type of proof is the multiplication property of equality. So multiplication prop of equality. So basically this means if A is equal to B, same way, then A times C has to be equal to B times C. Now this works too. So instead of taking 2, let's take a different number, just for variety. We'll take 3. So if A is 3, meaning B also has to be 3, we would get 3 times, and C will be 5. So we'll get 3 times 5 is equal to 3 times 5. Now this makes sense. So we get 15 is equal to 15. Now that's the multiplication property of equality. Moving on, we have the div property of equality. So the division property of equality states that if A is equal to B, then A divided by C has to be equal to B divided by C. Now let's use an example. Say we have A is 3, and B is 3, 2. Then if we take 3 divided by, we'll take a simple number, C is 3, is equal to B, which is 3 divided by 3. Then we would get 1 as the answer. This is A, this is C, these two are C, and this is B, just for clarification. Okay. Now let's move on to something that you may seem like it's not really a useful proof, but I'll show you an example that makes it a really useful proof. So say we have this proof is called a reflexive. Reflexive property of equality. Okay, and this just states that A is equal to A. So you might be thinking, well, that's obvious, duh. Like 2 is equal to 2, 3 is equal to 3. That's obvious. But in numerical values, that seems obvious. But in a geometric standpoint, when we have figures and we're trying to calculate the side length of figures, that might not be the case. So say we have a shape like this. Like, I guess, something very weird like this. Okay, so we have this shape right here. And say that this is point A, this is point B, C, and D. Okay, now say that this length is A, and this length here is A, the one right here. So that might not be obvious to us because they don't look the same. But when in the geometric standpoint, when we have A here and A here, we know that this has to be equal to this. So this is where the reflexive property of equality comes in hand. Or this could be B and this could be B. We don't know that for sure because we don't have any values and we can't just measure with the ruler. So this is where the reflexive property comes in hand because B can equal to B and it tells us the side lengths are equal and A is equal to A. Okay, now let's go on to the symmetric property of equality. Okay, now the symmetric property of equality is a fairly simple one. It states that if A is equal to B, then B has to equal A. So that makes sense. Because with this property, if we say A is equal to B and B is equal to A, if I draw the same figure like this, if I draw the same figure like this, 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 and this, then, and this is A and this is B, we can see that A is equal to B, so B has to equal A. So these two sides are equal. They are equal. Okay, now let's move on to the transitive property of equality. Transitive prop of equality. So the transitive property of equality is also fairly simple. Say we have A is equal to B and B is equal to C. Then from this we can easily know that A has to equal C. Because here we're saying A is equal to B. But then that B is same getting shifted over here and it's saying that B is equal to C. Well, in this equation right here, or in this proof right here, we're saying that A is equal to B. So A and B are the same value. Meaning if B is equal to C, then A also has to be equal to C. Okay, and the last property we have is the substitution property of equality. So substitute property of equality. So the substitution property of equality just states that if A is equal to B, then B can be substituted for A. Then, okay, let me just write that lower. Then B can be substituted for A. So that's the substitution property of equality. Because if A and B have the same value, then it doesn't matter what value you take. Because either way, you're going to get the same answer. Okay, so those are the 8 algebraic proofs, well, the main 8 algebraic proofs. I hope you liked the video. Please don't forget to like and subscribe. And comment if you have any other video suggestion ideas. Thank you for watching.